Find the critical numbers of the function h of x equals x to the sixth times e to the negative 7x. Again, critical numbers are where the derivative is either equal to 0 or undefined, so we need to differentiate. We've got h prime of x equals, and we have to use the product rule here. So we've got the derivative of the first, which is 6x to the fifth, times the second function, e to the negative 7x, plus the derivative of the second function, which is going to be negative 7 e to the negative 7x, and then times the first function, x to the sixth. Let's clean this up a little bit. We can pull out an e to the negative 7x. Let's do that first. E to the negative 7x, and then the leftovers, when we factor that out, are 6x to the fifth, and then minus 7x to the sixth. And it looks like we can pull out an x to the fifth here as well from each of those. So we've got x to the fifth times e to the negative 7x times, when we pull out an x to the fifth, that's going to be 6 minus 7x. And we want to know when this is equal to 0 or undefined. Now, there's no point at which this is undefined. The polynomial factors and the exponential factor are defined for all real numbers. So really, we just need to know when this equals to 0. And if we look at each factor, x to the fifth equals 0, specifically when x is 0. So one of our critical numbers is x equals 0. E to the negative 7x is never equal to 0. We cannot raise e to a power and end up with 0 as an answer. So that one is not going to give us any more critical numbers. And then this last one can be set equal to 0. 6 minus 7x equals 0. If we add 7x to both sides, that gives us 6 equals 7x. And if we divide by 7, that gives us 6/7. So our critical numbers are going to be x equals 0 and x equals 6/7. These are going to be the candidates for local maximum and minimum values, which is something we're going to be looking at soon.